Okay, so class, we are going to start it now without wasting time. You already know this thing that, we have spent it 4 5 minutes. Yes, so there are some viewers here on YouTube. Let me see what's going on there. Okay. If you're facing any doubt, please text me in the chat box. See, thoda echo to rahega. Today there will be some echo. Okay. है ना? So please, if it's fine, then please text me in the chat box. Today I'll be available here on the YouTube chat box also. Got it, students? Today I'll be available here also. So let me write here something. Hello, everyone. So I've texted on YouTube chat box, hello, everyone. So you can also reply there if you want. है ना? Otherwise, no issues. So okay, let us now start. I hope I'm audible. Okay, students. Go to the cloud. So the recording is started now. Okay, so now let us start it. Yeah. So let me check on the YouTube what is happening there. Okay. So let us start it now. Okay. ठीक. So next slide. See, in the previous class, I'll be very fast and very simple here. Okay. So in the previous class, what we have seen, if you see here, see हमने क्या क्या चीजें cover कर लिया था, हमने क्या क्या चीजें cover कर लिया था. So what is this? It's critical angle. It was in the revision. We have studied this thing, a ray is going and what happens when it gazes the surface. Next thing we have seen about total internal reflection. Something is known as TIR. Then we have seen we have solved a numerical based on that. Okay. So today we'll again see a little bit of these things. Yesterday in class we understood this apparent depth. What is known as apparent depth? We studied that thing. Okay. Then talked something about the normal shift, but the time was up. And that's why I ended the class. Okay, that's fine. Today we'll see refraction through the glass slab. Then we'll solve some numericals also. After that, we'll be seeing about the lateral shift and maybe one or two numerical we'll solve related to lateral shift. If we are left with some time in today's class, students, we will be also studying one thing, that is refraction through lenses. Refraction through lenses. Refraction through lenses. Okay. Yes. So now let us see. See what I've told you about critical angle thing. What was critical angle thing? You know this thing. Suppose you're having a boundary. Okay, let me draw this boundary properly. Proper drawing is required. Suppose I draw a boundary, a straight line like this. Okay. This is a boundary which is basically separating two mediums. Okay. This is a rarer medium. I'm writing the subscript R for rarer medium. I'm writing the subscript D for denser medium. This is refractive index of rarer medium. This is refractive index of denser medium. Okay. So suppose there is a ray of light. See, students, suppose this is a normal. This is something which is, say, normal. Okay. And suppose a ray of light, okay, it passes like this. This is a denser medium making an angle. This ray is making an angle theta with this normal. Okay. So when the ray of light passes from the denser medium in the rarer medium, it gazes the surface like this. Okay. And this angle is, here it is 90 degree. Got it, students? So we write here like this: ND sine theta is equals to NR sine 90 degree. And if someone says you, suppose this is oil and this is water. Why I'm saying oil water? Because water is a rarer medium than oil. And if we take, sorry, if we take air also, then air here is a rarer medium than this denser medium. Okay. So I'll write here like this: ND, which is a denser medium. And of course, this is sine 90 degree. It will be 1 NR. So you will get this critical angle, which is basically theta, for which this refracting, I'm not saying reflecting, I'm saying refracting ray is gazing the surface, and it makes an angle of refraction is 90 degree. So this will be equals to sine theta. See, where this theta C is the critical angle. What is that? Critical angle. It's a critical point where the ray turns completely 90 degree or gazes the surface. And this theta C is given by this, that is sine inverse NR by ND. Got it, students? So, students. Okay. Yeah, then we have seen, if suppose we're having a source like this, a source of light like this. Okay. And you know, the rays are going from this source in 3D. Okay. And suppose all the rays which are passing from this moody medium, which is having the higher, denser refractive index, towards a medium which is having the lower refractive index, when it passes from this medium to that medium, suppose it gazes the surface like 90 degree, 90 degree, 90 degree. And the locus of all such points, students, will give you a circle, by the way. Locus of all such points will give you a circle, by the way. Okay. And the circle is known as circle of luminance. These all things we have already discussed in the previous class. Now, what about next? Next, we have seen this video. I'll like to launch this video again because it's very cool animation. Okay, so let us see together. 1, 2, 3, start. So what is this video about? It teaches about, and it gives us an example of the application of this concept of TIR and critical angle. Okay, let me write it here. Now we'll be seeing. So if we see a little bit about the applications of TIR, critical angle. Little bit about the application of TIR, critical angle. Okay, so we can say what are the simple example, like in technology and science? So in technology and science, the examples are like optical fiber. What's the next example? The next example is like this. We can say like this. Optical fiber. A natural example, Mirage. Mirage is one of the best example. Sometime when you go in the desert with some camel kind of thing. Camel, I can't draw like this. It's somewhat like this. It's having hump, and it's like this. It's having feet also. Oh, it's like this. Okay. So this is camel. It's ostrich looking, but no issues. So man is supposed standing on the camel. Okay. So what has happened? So, water looks, sometimes it looks like the image. Suppose some tree is there, like khajur tree kind of, okay, palm tree like this, okay. So it appears upside down due to the mirage effect from the atmosphere. Okay, so we'll now understand this thing in this video. So I'm launching this video for all of you again. Are you ready, students? Yes, sir, we are ready. Okay, so I've launched it.
Now, what is a
Okay, students, so I've launched the video. I've shared the sound also now. Okay, so see it again.
mirage? An invisible cloak? No. Mirage is an illusion in which it appears as if there is water present on the ground. On a hot day, the land heats the layers of air closer to it. However, as we move higher, the layers of air get relatively cooler. Thus, the hot lower layers of air near the ground form rarer media, and cold upper layers form denser media. Now, when light coming from sky travels from denser to rarer media, it bends more and more until it exceeds the critical angle, that is, the angle beyond which light gets reflected. This phenomenon is called total internal reflection. When this reflected light reaches our eyes trace it backward as a straight line. Hence, the reflection of blue sky appears on the ground and our brain thinks that there is water, thus causing a mirage.
Okay, students. So I hope that you enjoyed the video, है ना? So whatever, now let us see this question. This question I have solved already in the class. Okay, what does it says? So now we'll see it. So solution I'm giving it here, students. So it's written here, find the maximum angle that can be made in the glass medium. Mu equals to 1. This is what? Mu equals to 1.5. Okay. And if light is reflected from glass to vacuum, what does it mean? It says maximum angle batana hai that can be made in glass medium. That maximum, see, they have just changed the word. So how, like, the examiner, like the questionnaire can, he can try to confuse you. So maximum angle kitna ho sakta hai? Maximum angle is that critical point angle. Okay, that is critical. This is the max angle. अगर हम इस एंगल से ज्यादा एक्सटेंड करते हैं, the ray will get reflected. If you extend the angle more than this, then the ray will be getting what? Reflected here. Okay, so we'll write like this. Suppose you're having a glass medium. Suppose, students, this is a glass medium here. This is a glass medium. This is having a refractive index as 1.5. Okay. And suppose this is normal to this glass medium and this is air. Fine. Now suppose if the ray enters like this, making an angle which is equals to theta max or say theta c, then the ray which is passing will gaze the surface with 90-degree angle. Fine. So now you will write here like this, that is mu 1.5 sine theta c equals to sine 90. You know this thing, sine 90-degree into refractive index of air. So mu you will use for this glass, 1.5 sine theta c. 90-degree mu here is 1. This will be like this. So you will get theta c equals to, what's that? 2 by 3 sine inverse. Okay, got it? Now next thing is this. So find the angle of refraction in a medium and to the light is incident in vacuum, making angle equals to twice the critical angle. What does it mean? So angle of refraction in a medium is given here as n equals to 2. Okay. And they say that if the light is incident in vacuum, making an angle equal to twice the critical angle. इसका क्या मतलब है? Actually, I've given you this question as a homework. I don't know why people haven't attended. Maybe on the YouTube you might be texting. Okay. So इसमें ऐसे होता है कि see, find the angle of refraction in a medium and equals to the light is incident in vacuum. First of all, you have to find the critical angle for such thing. Twice the critical angle. For this, you have to find the critical angle. Okay. So first of all, I have to incident this from glass, from this medium, say n equals to 2. So theta c for this will be, it will be equals to 1 into sine 90 degree equals to sine theta c. This is a homework question solution I'm giving you, providing you here. Okay. Sine of theta c into refractive index 2. So this will give you half as theta c angle. Sine theta half is when theta c equals to 30 degree angle. इसमें half होता है ये. Okay. So you get the critical angle is theta degree. Now it says that if the find the angle of refraction in a medium, if the light is incident in vacuum, making an angle equals to twice the critical angle. So you got the critical angle now, 30 degree for this pair of medium. Now, if you need the twice of this angle, that is twice of 30 degree, that is equals to 60 degree now. Okay. So how you'll solve? So it will be like this now. Suppose you're having this boundary and the ray which is incident in vacuum. So it's incident from, suppose this is now vacuum. So they're asking the angle of refraction. Okay. See, read the question again properly. Find the angle of refraction in a medium n equals to 2. If the light is incident in vacuum, it's vacuum or air, where n is equals to 1. Okay. Angle kitna hai incidence? It's equals to twice of critical angle, that is 60 degree now. Angle of refraction they're asking. Simple. So suppose now a ray passes like this. This is theta of critical, that is equals to 60 degree. Okay. Another ray passes like this. So this is theta c angle. Okay. They're asking the angle of refraction. Suppose this is normal here. ये normal है. अगर रे refract करेगा तो theta c 60 degree angle and so if the refraction have to occur, we'll say what? I mean, they're asking the refraction angle made by this ray. So when the ray passes from a vacuum to a denser medium and equals to 2, whether it will move away from the normal or towards the normal, what do you say? Sure, it will move towards the normal. Okay, so I'm writing here, it will move towards the normal like this. This will move towards the normal. So this is an angle we'll write here towards the normal. मतलब कितना होता है? Some theta, say r. Okay, let me write this angle theta r means angle of refraction. Fine. So when we'll solve this thing, you'll get what? 1 sine of theta, it's twice of that. So it will twice of theta c, it means 60 degree. Sine 60 degree, sine theta 3 into 2, refractive index of the medium. Sine 60 degree is what? It's root 3 by 2. Okay? And upon 2, this is sine theta r. Okay, students? So theta r here will be equals to a sine inverse of root 3 by 4. So this is the angle of refraction. Okay, this will be your angle of refraction in this case. Now homework solution is completed. Now let us see the next things. Yeah. So in the last class, we ended the last class in 15 minutes by taking this topic, that is apparent depth and the real depth. What is this thing known as apparent depth and real depth? Okay, let me write it here. Apparent depth and real depth. Okay, students. So I told you what, that if suppose there is some fish like this, originally at the depth of say this, capital D. So it will appear to your eyes that it is not here, but actually it is here, apparent depth. Okay. So we'll write here. So there is a formula for this, finding the apparent and the real depths in connection with the medium's optical properties, that is refractive indexes. So this is suppose N1 refractive index of air is 1, and this is suppose N2 refractive index of medium equals to, since this is water, it will be, of course, it's sure it's 1.33. Take. Now there is a formula connecting these four parameters, that is N1, N2, and say real depth, say elusive, fake, not genuine, apparent depth. Okay. So let us connect these four things, four parameters. So the formula is what? Formula is this. That is, this we have seen in the previous class. देखा था ना? This we have seen in the previous. This we have already seen in the previous class. Got it, students? Fine. Now, this question was pending. Okay. So how to solve this question, by the way? How will solve this question? Okay, I'll be solving this question in front of you. Let us see. But for before this, let me see what's happening on the YouTube. What are the YouTube students doing there? What are all those YouTube students doing there? Okay. So just hold on, students, for a second. Let me see the YouTube. What is happening there? Just hold on. So I've texted there about any doubt. If you're feeling any doubt, please text. Okay. Okay, leap. So for how I'll solve this first question, let us see this first. Okay. So in this question, what I did is that you can see here there's a bird. Okay. And this bird says the fish original. I mean, they're saying that what will be the distance which will be visible to this bird of this fish. Okay, apparent. So since the fish is here, it will appear to the bird that it's somewhat rise in height, or we can say it's like less in depth. Apparent depth will be there as compared from the surface. So let us take this depth as d dash. Okay, if we connect the formulas will be like this. So 4 by 3. Okay, let me write this. So we'll write like this. The formula is this: n2 d dash and n1 d. What does it mean? Okay. Simple. It is just connect both the formulas. So n2, you can see here in this formula, n2 is the refractive index of the medium where the ray is going. Where the ray is going. Suppose if you see above, n2, the formula is this: n2 upon n1, apparent depth. Apparent depth is where? It's d dash. Okay. D dash upon d. Okay. If you multiply both these formulas, cross multiply, you will get like this: n1 d dash, n2 d. इसका क्या मतलब? What does it mean? n1 d dash, n2 d. What does it mean? It means like this: n1 is the water medium. Okay, connect this with the apparent thing. Water matlab apparent. Real matlab this is air is what? The original practical thing, real thing, genuine. Connect with this with the real depth. Okay. Similar I will use in this funda here. That is, I will say like this. This is d dash apparent. So I will connect this with apparent water. Okay, because water shows you the illusion. Okay. So d dash I will write here. I will connect the real depth, that is 36 centimeter, with the real medium, that is air. So when you will solve this thing, you will get the answer as 43 upon 36 is 3 1 3, 3 2 6. This is 48 centimeters. Am I right? Am I right? I think so. Now, so this will give you 48 centimeters as the answer. So from the surface, no, this is wrong. Hold on. 4 by 3 is the mediums. It's D dash. Okay. So we'll connect this thing. N1 into D dash and N2 into D. N1 into D dash and N2 into D. So that's fine. What's the formula? So N1, this is 4 by 3 into D dash if connected. This is the apparent depth. Okay. And N2 into D. So N2 is the top one that is having the one medium. Yeah, fine. Okay. So you'll get answer this 48 centimeters. If you see from the bird's view, this is 4 by 3. 4 by 3 means kitna? Water ka kitna hota? 3, 1.33. Okay. So you can say like this is 4 upon 3. If you see the formula again, the thing will be same. N2 stands for what? N2 is the above one. N1 is the initial one. Okay. So N2 is the above one. That is air into real depth. And N1 is the fake one, apparent. So N1 is what? 4 by 3. Apparent depth is, I don't know. Real is water, real is the air, and real depth is 36 centimeters. So if you multiply this will be here. So this is a mistake here. 4 by 3 will not go like this. It is 1 upon 4 by 3. So when you will solve this thing, let me write it here. When you will solve this thing, you'll get like this. That is 3 by 4 into 36. This is 27. 3 by 4 upon 36. This is what? 27 centimeters. Okay. So this is the apparent depth, which is less. That's why there is a problem. Okay. It must actually appear to the bird's eye that the fish is not at, or it's suppose it's an eagle. It must be here. Okay. Less than 36 centimeter. Second question is the opposite of this. How you'll solve that? That now they're saying what the fish will look. I mean, what the bird's distance the fish will feel. Okay. So fish will feel like this, that bird is not near, but a bird is far away from the surface if we see. So fish will see like this, that the bird is far away. Like this. And that is the basically apparent thing. And the real is actually 36. Okay. Now I'll use the formula again. So you will say that for the second part, I'll solve here. It's very easy. Apparent matlab, apparent matlab 4 by 3 D dash. Real matlab 36 into 1. ठीक है. इसको solve करेंगे अगर हम hold on, इसमें फिर mistake है कुछ. It's 4 by 3 is this thing, and this is the real one. So when you solve this, you'll get a greater distance there. Okay. Fine, students. So this is great distance, and okay. So apply this formula here now. You'll get it. इसमें क्या करना है? There is some change here. In this, when okay, let me make a proper diagram there. Okay. Next slide. Suppose you're having a medium here, and this is a bird here. Okay. And this is actually a distance, real distance is 36 centimeter. And fish is at the real depth of 36 centimeters. Fine. So in the air to the fish, the bird must appear greater than this distance, D dash. This is the real one. And the fish is at this, say, depth. Okay. So we'll say like this is the medium 4 by 3, this is 1. So apply the formulas. Formulas will be like this. 4 by 3 into 36, that is 4 by 3 is this medium. So this is the real depth of this, I mean real depth of this bird, which it will see it is 36, into we'll add D dash into 1. In air the illusion is happening now. So when we'll solve this thing, this will come out to be 48 centimeters. Okay, and this is the right answer. That is apparent to this fish, this bird will appear that it is at 48 centimeters, which is far away. Okay, which is far away. So what is the conclusion? Conclusion is this. When the bird will see fish, to bird's eye or eagle's eye, it will appear like this, that the fish is near than actually it is. Okay, so we have seen here that was the distances. It is apparently at 27, but actually it was at 36 centimeters of depth. Okay. And second point is this. that to the fish, bird will appear. To the fish, the bird will appear as such that it is far away. So उसमें तो near it will appear, but इसमें far away than it is. Okay, so if we'll write the distances here, we'll write like this: D actually for the bird is what, 36 centimeters, so it's appearing far away. Apparent is what, it's greater than this. देखो water में it's less, you can see this, but इसमें it is greater, that is like this. D dash is greater, that is how much it is equals to anyone 48 centimeters. So this is what the beauty of this refraction process. Okay, how the rays transfers and all these things. Got it, students? Now let us see the next slide. Yes, now there is one more question based on this concept in front of you. What does it say? It says like this: suppose now the bird is moving with the speed, but heading towards. Now the bird, suppose its head is heading towards the fish with 24 centimeter per second. Okay, and the fish is also heading towards the bird with 12 centimeter per second, and this water surface is also moving with 1 centimeter per second. So now the first question is this: they're asking from you that you have to find the apparent speed of the fish as observed by the bird. Okay, and next is this, that is the apparent speed of the bird as observed by the fish. So what's the differences? What's the difference? Okay, we'll see now. For this, we have to understand this concept, speed concept in case of refraction process. Okay, suppose this is a medium, a boundary which is separating two mediums, N1 and N2. Okay, since we can see that the angle of refraction is greater than I, so this medium is, we can conclude this medium is denser than the I's medium where we are there. Suppose we are in the air or vacuum, and this is maybe water or oil. So speed relation, when you will solve, you will get like this, that velocity of the image with respect to the surface, okay, equals to n2 upon n1, velocity of the object with respect to the surface. Velocity of image with respect to surface equals to n2 upon n1, velocity of the object with respect to the surface. Got it? Now we'll apply this thing. It's a direct formula. No need to remember all the things, derivation and all these things. Just remember this formula and you'll get it. So इसको जब apply करेंगे इस पे, so in the first part, what is happening? It says the bird is moving 24 centimeters per second. Okay, so these are the pictures. Let me show you. So it says like this, that there is a boundary. Let me draw it properly. There is a boundary which is separating two mediums. Water, 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 water. This is what? Air. Okay. And suppose the ray passes from, object is inside. So I'll write the simple formula, fish. This is suppose fish. Okay. And it's moving with, say, speed equals to above towards the bird, heading towards the bird with 12 centimeters per second. Okay. And this is what? This is what? A bird here. This is bird. Okay. And this bird is moving or heading towards this fish towards twice of the speed, but towards it, I mean opposite direction. And this water surface is also moving like 1 centimeter per second. So we'll apply this formula now. Okay, we'll write like this. N1, this is N2, by the way. N2 is what? You can see this, how it's written. Okay, so it's N2. N2 is 1 here, N1 is it's water, it's 1.33. So velocity of image, image kya hai yahan pe? First question is what? First question is apparent speed of fish as observed by the bird. So we'll say like this, velocity of image minus velocity of surface. It will be minus, it will be plus 1. Okay, positive is this, negative by silent convention I have taken this. So N2 is 1, it's basically 4 by 3, hai na, upon 1. Hold on, some mistake. So we'll write here N2 upon N1. 1 is this is 4 by 3. This will give you 3 by 4. Velocity of object is how much? Object is above 12 centimeter per second. Okay, minus of 1. Fine, because it's positive. This is the object basically, okay? So this will give you the answer as 12 minus 1. 12 minus 1 is basically what? It is 33 by 4 plus 1 will give you velocity of image, okay? So this answer is 37 by 4. Okay, once you get the velocity of the image, now with respect to bird, what does it mean? So velocity of the image is positive. So with respect to bird, मतलब velocity of image with respect to bird का मतलब होता है velocity of image minus velocity of bird. ठीक? So put it like this: 37 by 4 minus velocity of the bird is actual vector velocity of bird is minus 24 centimeter per second. So minus of minus will give you the answer here. That is 37 by 4 plus 24. So by solving this, you'll get the real answer. Okay, so this is a solution of the first part. Second part is again is a homework for you. Okay, use this relation, this concept, that is this formula, this funda here. Use this formula and you'll get the answer. It's very easy. Okay, derivation is also fine. You know, you just have to put the previous one here. That is, if the object is this and N1 is the air medium, you'll use like this. That is N2, which is the air medium, N2 into the real depth, that is X. So for real air, real depth, N2 into X. Fake thing, that is medium, fake depth, that is this Y. So Y fake depth, fake medium is what here? N1. Take, and you'll use this, put Y up, Y equals to what? N2 X upon N1. इसको differentiate कर दो बस, like this. Answer bar. Okay, got it? Okay, now one of the students have joined, laptop 27 have joined. So, I mean, I don't know your name. How are you? So you have joined late, but no issues. Okay, that's, I really appreciate you. Very, very good. Excellent that you have at least joined the class. So this shows your seriousness. Very good. Cool. Okay. So now we have completed this. Second part is the homework. Okay. Whatever your name, I mean the student. The second part is the homework for you. You have to use the upward trick. So when you will see the YouTube video back, you will understand. Okay. So now we'll see, let us see this topic, that is refraction through glass slab. Refraction through glass slab. What is it? If you see here carefully, this is known as incident ray, by the way. This is something known as incident ray. This is something known as emergent ray. Okay. Incident ray is this. Emergent ray is this. Okay. And perpendicular distance between both of these rays. If you see perpendicular distance between both of these rays, you can say, suppose it's like this. You know, this is basically known as students' lateral shift. You will say, sir, what is happening in this? Actually, this is some glassy slab, a material, rectangular material of glass. It's known as glass slab. So suppose from the object, a ray is incident like this. Okay. So when it is incident at a point here, it goes inside and it comes outside like this. The one thing, the point to be concluded here is this. That is incident ray. Incident ray and emergent ray are both parallel. So the same ray have came out from the other side and it's parallel to the initial direction. Parallel. Okay. Also, but there is one thing, that is emergent ray shifts laterally. Emergent ray, which is parallel to incident ray, has shifted laterally. Shifted laterally. This is the point here. Okay. And this distance is known as, by the way, D, which is the lateral shift distance. Lateral shift distance. Here it is known as T by cos r sine I minus r. Remember this formula, it is important. Okay, we'll solve a question based on this now. I hope you understood the person in the chat box. So student here, laptop 27 by the name of this. I hope you understand this thing. Is it fine? Okay. So we'll write here like this. Okay, let me write the formula first of all. This is the formula. Let me explain you how to apply this formula. Okay. This D is this perpendicular lateral shift of the incident ray, so-called incident ray, which has now shifted to this position, say D, okay, from its initial direction. It is equals to this T here is known as the thickness of the slab. T here is known as thickness of this glassy slab. Cos R here is the angle of refraction. I minus R, angle I is known as angle of incidence. Angle R is known as angle of refraction. Okay, so these are the things. T cos R sin I minus R. So now we'll see here. So we'll see D, which is a lateral shift here, equals to T upon cos R sin I minus R. Take. So T is what here, students? T is the thickness of the slab. It is 10 centimeter. Cos R is what? Cos R you will write as what, students? This is R angle. So I'll solve this question for you. See, first of all, let us read this question. Okay. Find the lateral shift of the light ray while it passes through a parallel glass slab. Diagram is given below, okay, of 10 centimeters. So they're given the thickness of the slab as 10 centimeters. Let's find thickness T here is 10 centimeters. Then they say that if it's placed in the air, angle of incidence of the air is this, angle I equals to 60 degree. And now they say the angle R is equals to 45 degree. So when we'll solve all these things, T upon cos R here is basically 45 degree angle, and sine of I minus R, I here stands for what? 60 degree minus angle of refraction, that is 45 degree. Okay. So from this you will get here, that is D 10 centimeter. Cos 45 is how much? It's 1 by root 2. Okay. So this is root 2 here. Sine 60 degree minus 45 degree. 60 degree minus 45 degrees, how much? It's 15 degree. Okay, if you write it, let me show you this thing. It's 15 degree here. Ten root 2 sine 15 degrees this. Got it? The thickness you will get like this, 10 root 2 sine 15 degree. It's not a thickness, this is the lateral shift, which was asked in this question, okay? I hope it's clear to you. So in the chat box, you can text me if this solution is cleared. I hope it's cleared, huh? So now let's move toward the next thing. We are having less time. Yeah, one more thing, students. Apparent shift due to slab when the object is seen normally through the glass slab. Okay. But before this, because we are having a less time, I would like to clear some other topics also with related to this. So what happened? Okay, let us see this topic only. Okay. So see, if it is here, this is O object. So this is a glass slab. This is something known as glass slab, which is having a thickness equals to T. See, this ray from the object goes, and this is having the first process refraction here. The first process of refraction occurs at this side of the slab. First refraction process. Okay. Due to this, the ray turns like this, and we can see the first image formed by this. This is the I image, which is at D dash distance. Okay, from the surface. And when the ray emerges out, and if you see this ray, you will find the image like this is the final image due to second refraction, the final image. Okay. So what you will say, basically from your perspective, from yours eye perception, you will say like this, that the image, the final image is formed where? Due to the final refraction. Due to the final refraction, the final image is formed where? You will say it is formed here. So you will say like this, that the object is actually, you will read what from this side? You will read this, that this is the object. But actually it is what? It's the image. है ना? So that's the apparent shift. And this apparent shift here, you can see with your eyes that this is given by here S. So this S quantity is the apparent shift. That is the distance between object and the final image formed. This S is the apparent shift. Okay. And this is given by the formula, which is this. This is the formula. This is the formula which gives you the apparent shift between the final image. Okay. This says thickness of the slab 1 minus 1 upon mu, where 1 is the refractive index of air and mu is the refractive index of medium. Fine, students. Okay. And the medium is not air or outside the slab. We'll say like this. Shift will be like this. That is, suppose students, it's me kya keh raha? What is it says? Next formula teaches you what? What is it's want to explain? It says like this. Suppose you're keeping the glassy slab, which is having the mu of the slab, and not air, because air में रखोगे तो mu तो 1 हो जाएगा. Not in air, but in some other medium which is having the mu, its own mu of surrounding, which is not 1 actually. It may be say water. Suppose you keep a glass slab in water, so it will be 1.4, not it's 1.33, and this glass will be having 1.55. So for this case, you will use this formula. Okay. Don't forget to use this T, by the way. This is thickness of the slab. Okay, that's fine. Okay, now let us apply this formula first. Okay, few more points, important points which are required to understand. Rays should be paraxial. It means having the very less angle of incidence. Medium on both the sides of the slab should be same. Matlab, it must be like this. If this is a glass slab mu, so यहाँ पे if it's air, everywhere it must be air only. If there is water, you will use everywhere. Matlab, keeping the glass slab in a water or in air. Shift comes out from the object. So it's like this. See, if the shift comes positive, it means towards the direction of the incident rays. If it's come negative, it is opposite to the direction of the incident rays. Let me explain you this thing. Okay. So you can see here properly with your eyes key. This is object. This is the final image. Shift is S. This will be positive. Okay. If the final image is formed here, say I2 is formed here, shift will be negative here. Okay. So if you see that the image is near from your perception, you will say it's the shift will be positive for that. If you perceive like this, that the image is far away from the original object location, you will say that the shift is negative because it is opposite to the direction of incident rays from the original object. Got it? So now let us see this thing, solve a numerical, and then we can, I think, end the class. Okay. So solution of this, check it out. It says calculate the shift produced by a glassy slab, a glass slab having the thickness equals to 15 centimeter and refractive index, of course, it is 1.5 of the glass slab and kept in air. See, if it says if it is kept in air, it means everywhere there is air, air, air. It's surrounded by the air. It's in the air. It's in the space vacuum. That is N for this is 1. Okay. Now we'll apply the formula for the shift. You can see here carefully that shift comes out to be, what the shift is? It is this T1 minus surrounding medium ka refractive index upon mu of slab. So you can see here carefully that surrounding medium ka refractive index is 1. Slab ka refractive index is 1.5. So shift comes out to be T is how much? T is the slab thickness, 15 centimeter. 1 minus 1 upon 1.5. 15. This will come out to be what? 2 by 3. So when we will solve this completely, we'll get the answer shift as 15. 1 minus 2 by 3. Okay. Where this is basically 1 by 3, that is 5. and it's positive. So the shift is positive. It means if the slab was this, mu of glass, and rest is air on both the sides, and if the object is actually here, this is suppose object location, shift comes out to be positive, it means shift is +5 here, and this is the final image. And you will see with your eyes that you are seeing that image is at this location. Okay, but actually it is where? Actually, the image is not at this location, but it is at this location. Okay, the shift is positive means in the direction of the incident rays. If it's negative means object image will form there. This will give the shift negative direction. Okay, that's fine. Okay, now students, you will use this concept. So this question is the fusion of, this is a combo fusion pack. Okay, so it's like this. It's a fusion of two questions, two concepts. Okay, that is refraction through glass slab and a concept of concave mirror reflection is used. It's a combination of mirrors, combination of reflecting surface and this concave mirror. Okay, so इसमें क्या करना है? इसमें एक object दे रखा है. You can solve it yourself. This is the object. Okay, अगर ये slab नहीं होता, if this slab is not inside it, what's going to happen? This ray will go directly and will use the distance of the object is 21 centimeter. You will use the formula 1 by v plus 1 by u equals to 1 by f. You'll find the image. But now this slab is, since this slab is inside, so first of all, you will say, if you're standing here on this principal axis, if you're seeing here on this principal axis, you will say like this, that object is not at, suppose you are on the pole. This is a more better thing. Suppose you are on the pole. So you will say like this, the object is not at 21 centimeter, by the way, but object is nearby to it. Some shift is there in the object. Okay. So suppose shift, let us find the shift first. Okay. Because the slab is there. So if I find the shift is thickness of the slab, which is 3 centimeter. 1 minus air is 1 by mu surrounding medium, and slab is 3 by 2. So this will give you the answer as 1 minus 2 by 3 as 3 into 1 by 3. This is 1 centimeter. So shift in the slab comes out to be positive. What does it mean? Iska matlab hai, now you will see that due to glass slab, you will see the object ka naya position is this O dash, which is basically, if I write here, it is you will treat as with the sign you will treat from the pole u as minus of 21 centimeter minus 1 centimeter, that is minus 20 centimeter. So u will be minus 20 centimeter because there is a shift here, no? Object yahan aa jayega. So this will be the new position of the object, that is object distance. So now the question becomes like this, that question kaise ban gaya? Question becomes like this, that there is a concave mirror like this, and there is the principal axis like this, and the object is here, pole is here, and now the object is at shifted somewhat towards the plane mirror. Suppose towards the concave mirror, that is shift is positive. It's minus 20 centimeters. So its location is 20 centimeters from the pole. 20 centimeters from the pole. Okay, and radius of curvature of the pole is also 20. So we can use the concept of rules of image formation. Iska matlab object is at 20 centimeter and the radius of curvature is also 20 centimeter. It means like this, that this O dash point basically is the center of curvature. Center of curvature. Okay, इसका क्या मतलब? इसका मतलब ये हुआ कि if you know the rule, important rule, if object is at center of curvature, image forms at same point. What does it mean? It means that if the ray passes from center of curvature, or it passes from center of curvature, okay, or if ray is incident from center of curvature. So after reflection from concave mirror, it will retrace its path. Got it? So the rays like this, after reflection, it will retrace its path. So image will form at the same position. Okay. So the question was this: where will the final image forming? You will say it will form at this v equals to -20 only. See, if you want to cross check this thing mathematically, you can cross check like this. Use the formula. Very good. Use the formula. 1 by v plus 1 by u for concave mirror. Focal length. Focal length is r by 2. For concave mirror, if we start from the pole, it will be negative minus f. F will be basically negative, that is minus r by 2, that is minus 10 centimeter. R is minus 20. Okay, put here minus 10. You are given here as minus 20 only. Isko solve karoge, you will get this 1 by 20 minus 1 by 10. When you will solve this thing, what is coming? Half minus 1. This is minus 20 again. So from this, students, we can conclude this thing that V is equals to minus 20 centimeter. That is on the same center of curvature. So is it fine? It's proved, cross-checked. Okay, so we have seen the physical significance theory. Now we have cross-checked with mathematics. So it's same. Okay, so we'll say in this case, image will be forming. You have to find the final image. So we'll say final image is forming there only. Got it, students? So that was all about today's class. Thank you so much. You have seen all the things now. Okay. So bye-bye, everyone. Take care. Study well. We'll meet in the next week, Saturday, Sunday. Okay. Bye-bye. Tata. Okay. Bye, everyone. So I'm ending the class now. Time is up. I'm ending the class. If you're feeling any doubt, please text in the chat box. If you're facing any doubt, please text in the chat box, or you can leave the class. Okay. Time is up.